Hello everyone, and welcome to question number 14 of the Machine Design and Materials exam that is offered for free at engineeringappliedpractice.com. So this problem is another sort of classic statics problem. Let's go ahead and read the problem statement. Two cables, AB and BC, are used to suspend a mass M in the air, where mass M is equal to 15 kilograms. Find the tensile force in cable BC in newtons. Okay, so let's look at this problem. We can see that in this problem we have A up here, B is in the middle, and C is on the end. We're looking for force in BC here. FBC is what we're looking for in newtons. And so on these problems, sort of selecting a good spot for a free body diagram makes all the difference. In this case, let's go ahead and select point B. So looking at point B, we're going to ask ourselves what forces are acting on this body. And so the first one we can say is force AB. The second force, and the one we're solving for, is going to be FBC. And lastly, the force is coming from the mass. So I'm going to put mg. And that's it. That's all the things that are sort of tugging at this central position B. So what do we do in almost all statics problems? We are going to do a force summation and use Newton's second law to solve this problem. So the first thing that we'll do just to get the necessary information and solve for FAB is sum the forces in the y direction. We're going to say up is positive. So we're going to say FAB y is positive minus mg is equal to 0. So what do I mean by FABY? Well, there's the component of FAB acting this way, ABY, and then a component acting this way, FABX. So how does that actually break down? Well, we know that this is 30 degrees here. So the component FABY is just simply FAB cosine theta. So we can also say that this is equal to FAB cosine 30, and this is equal to mg. So let's solve for FAB. It's equal to mg over cosine 30. So that's equal to 15 kg times 9.81 meters per second squared divided by cosine 30. So FAB is simply equal to 170 newtons. Okay, but FAB is not what we're looking for. We're actually looking for FBC. So let me draw a little divider here. Let's say now we want to sum the forces in the x direction with the right being positive. So we have FBC, which is what we want, minus FABX equal to 0. That's equivalent to FBC minus FAB, and in this case we actually get sine theta, which is sine 30. And so let's finish this off. We can say that FBC is equal to FAB sine 30, which is equal to 170 sine 30. So let's punch that in the calculator, and we come up with FBC is equal to 85 newtons. So that would be answer selection A. If you have any questions or comments, leave them below. Thank you.